Regarding the use of a 1/3 neutral reactor in a single-phase application, the answer is no. A neutral reactor, sometimes called a neutral grounding reactor, is a type of inductor specifically designed to limit the ground fault current in three-phase systems. Their primary function is to add impedance into the ground fault current path. This impedance reduces the magnitude of the fault current, preventing excessive damage to equipment and minimizing voltage dips during ground faults. In a three-phase system, the neutral point is a common reference point for all three phases. During a ground fault, current flows from the faulted phase to ground and then back to the source through the neutral connection. A neutral reactor installed in this path limits this current. The selection of a neutral reactor depends on several factors, including the system voltage, the available fault current without the reactor, and the desired level of ground fault current limitation. Calculations are performed to determine the appropriate inductance value for the reactor. However, single-phase systems do not inherently have a neutral point in the same way as three-phase systems. Single-phase systems typically use a line and a neutral conductor to provide power to the load. A ground fault in a single-phase system would create a short circuit between the line conductor and ground. Introducing a reactor in the neutral path of a single-phase system would not serve the same purpose as in a three-phase system. In a single-phase system, the function of a ground fault would not function the same way. It could affect the voltage. Ground fault protection in single-phase systems is typically achieved using ground fault circuit interrupters, often referred to as GFCIs, or other overcurrent protective devices like fuses or circuit breakers. These devices detect ground faults by monitoring the current balance between the line and neutral conductors. If there is a significant difference, indicating that current is flowing to ground, the device trips, interrupting the circuit and preventing electrical shock or fire hazards. The GFCI monitors the current flow to the load device. One example, 20 amps is flowing on the hot. The wire of the GFCI should see negative 20 amps to the source of the load device. If there are some lost electrical energy that doesn't return, that means electrical current is going somewhere else in a ground fault scenario. The fundamental difference in the electrical configuration and fault behavior between three-phase and single-phase systems makes the use of a 1/3 neutral reactor unsuitable for single-phase applications. A ground fault in a single phase does not travel the same way like it would in a three-phase electrical environment. The neutral in a single phase is just one of the wires to close the electrical current with the load device. A reactor would not do the same functionality as it would do in a three-phase electrical scenario. It is a specialized component designed for a specific application within three-phase power systems.